Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is Physics 5054 and lecture number 54 as well. Today it is the turn to utilize our knowledge which we gained in the previous two lectures, and today we will apply it practically, and we will see that whether we understood the theoretical portion or not. As you people are aware of the fact that in this book the pattern is that at the end of every unit they are testing your knowledge in two different ways. One way is that they are giving you multiple choice questions. Four answers are given for every question and you have to select only one. One is the correct one and three others are not correct. Then it comes the turn of a structured question. They are structuring different questions in detailed manner and they are testing your knowledge. So in this way we will apply our knowledge. Let us dive directly into the exercise which is on page number 139 of this book. Ladies and gentlemen, in the first question, they are asking listen carefully because writing it on the board is difficult. You have the book, refer to page number 139, and those who are not having the book, I can give you a snap of it. These are the questions, and you can see that there are four parts of it. And the second portion is of structure question. This is the section A, and this is the question number 1. The question number 1 is saying the phenomena of Brownian motion shows that an A is given as molecule exist and can be seen as bright dots moving. No, molecules cannot be seen inside the Brownian motion. Molecule moves about randomly at high speed. Uh, Number C is saying smoke particle behaves as a molecules. And number D is saying that smoke particles can be used as a model for air molecule. So here molecule moves about randomly, that is absolutely correct, at high speed, and that is what the Brownian motion is saying. We discussed the Brownian motion in yesterday's lecture, and we said that the haphazard motion of molecules. Again, I am telling you haphazard means random. And this B part is also saying molecules move about randomly at high speed. So in this case, I am writing that B is the correct option. Molecules moves randomly with high speed. With high speed. So this is the phenomena of Brownian motion. That was the whole story about the first question. The second question has given us two columns, and you can see these two columns are given. If you don't have the book for you, I am giving this snapshot. Stop it, observe it, and then play the video, and then understand my answer. Okay, because writing it on the board is difficult and wastage of time. A snapshot is better than writing it again. How does the motion of liquids molecules differ from that of a gas molecule? Yesterday we discussed the molecules motion of liquids. Not yesterday, before day before yesterday, in the lecture number 52 we discussed this. In the first, liquid molecules, and the second column, gas molecules. Okay, number A part, liquid molecules vibrate about their mean position. It is absolutely not correct, so we don't have to see the second column of it. Gas molecules vibrate randomly. Yes, it is correct, but the first one is not correct, so we cannot say that A is the correct. Now B, move randomly. Liquid molecule doesn't move randomly, so B, first column, is not correct. And the gas molecules vibrate energetically, so this option is also not correct. Now let us see what the C part is saying. About the liquid molecules, they are saying rotate and vibrate randomly. We haven't heard the rotate term in the theoretical portion. So the second, about gas molecules, they are saying vibrate randomly and energetically. This is also not correct. One is remaining, and that must be correct because one is the correct one. The sense is saying this. About the liquid molecules move randomly in liquid, yes. And about the gases move randomly with high speed, absolutely correct. So the D option in this one is correct option. The D one, you can see that, and then you can modelize it. Now the C part, the third question, is about the diffusion of the gases. The third question is here. Let me focus it. Yes, it is now. Diffusion of gases occurs because the molecules of an A part is given. And let us discuss it. The A part is saying the gas present in a higher concentration exert a higher pressure. No, it is not correct. The gases are different. No, it is not. Listen the question. Diffusion of gases occur because the molecules of the gas attract each other. No. The gases move about randomly. Yes, this is the correct answer, D part. Diffusion occur because the gases move about randomly. So here the answer of third number question is D part. Next one, the fourth one is saying that let me show you first for your convenience, and that is the question number 4. According to the kinetic molecular theory, the pressure exerted by a gas is caused by, and there are 4 options given to you, in which the first one is a gas molecules colliding with each other at high speed is not, bombardment of the gas molecule on the wall of the container. Yes, it is correct. B number part is correct. Bombardment of the gas molecules on the walls of the container. Yes, that is why, according to the kinetic molecular theory, the pressure exerted by a gas is caused. The C option also, let us see, random motion of the gas molecule doesn't uh, say that the pressure exerted. D part is saying gas molecules being very far apart from each other, so it is not producing or exerting any sort of pressure on the walls of the uh, walls of the gas, the tire on the wall, whatever the question is saying. So, in this fourth number question, uh, B is the correct answer. B part is the correct answer. Now, the fifth question and the final question, which I can show you, not the structure question, is this one. They given us a syringe, and in the question they are saying air air at atmospheric pressure is 760 millimeter of Hg is trapped inside a container as shown in the figure. You saw the figure of the syringe. There was a container and there is a piston. Air is trapped inside that container. What the question is saying, when the piston is pulled out slowly so that the volume is increased by 20%. Yes. So there are 2 methods of this question we will do. But let us first complete the question. The temperature remaining constant, the pressure of the air becomes. When you are increasing the volume of the gas trapped inside the container, the distance between those molecules increases. The distance between those molecules increases and the pressure will be decreased. First, it was 760 millimeter of mercury, 760 mm of Hg. I told you that there are 2 methods. Method number 1, we are saying that in this case we have to find 20% of the 760 mm of Hg. So we have to say that 20% of 760 is cancelled from each figure, and then it will be 2 and 152. So we have to subtract subtract this from 70, 760. So 760 minus 152 is equal to 608 mm of Hg. Ladies and gentlemen, that was the first method. My mathematics course, which is 4024, is describing this percentage increase and decrease in greater detail. If you want to learn more about that, go to my mathematics course of GCSE and IGCSE as well and learn that. In that course, I told you that if there is a decrease, 20% decrease, so it means 80%. So direct answer can be found 80% of 760. First we found 20%, and that is what the question is saying. And then we are subtracting that 20% from the original value of 760 mm. But here we can find directly. Why should we find this and then subtract it from the original value? We can find 80%, which is 20% less. So that is why I am writing 80% of the 760. So 80% of 760 mm of Hg. Again, I am cutting 110 with the 100. So when we multiply it directly, we will get 608 mm of Hg. So in this part, we are having in both cases 608, and they given us C is the answer. They given us in C part this 608. So that was the whole story about the first section. Now we are talking about the second section, and that is section number B, that is structured question. They are not MCQs. Four answers are not given. They are open-ended questions. The first part was a close-ended question. What does it mean? It means that you are restricted to answer one of the four given options. But in this case, utilizing your mind, you have to give us the answer whatever you have learned. So let us first say question number 1. Using the kinetic theory of matter, discuss why solids have a fixed volume and shape. Let us first discuss. There is another part of this question is, but first we are talking about. If you remember, then I told you that in solid, the pattern of the molecules arrangement is very closely packed. So there is strong intermolecular force inside the molecules, and the pattern is also very compact. So they occupy less space. That means that it is not getting the volume, the area in which you are putting these solid, they are not getting the shape. It has a fixed shape and a fixed volume, because the intermolecular forces amongst the molecules, the bond between them, are between the two molecules, are very strong, so they are not leaving each other to spread in the container. That is why we are having that it is having fixed shape and fixed volume. We are not talking about the motion, the movement of molecule. So that was the first case, and we studied that in greater detail in the 52nd lecture. The second part is where is gas have neither a fixed volume nor a fixed shape. Why is that? Because in gases, the molecules are spread apart from each other, so they are independent from the effect of attraction or repulsion of each other. Wherever you are putting these gas molecules, it will spread inside that container and will get the shape of that container. So because they are not strongly bounded by the intermolecular forces, so they are not having fixed, no fixed shape. Wherever you are putting it, it will get the shape of these that container, no fixed volume, because they are spreading apart, so they are not having any fixed volume. That was the whole story about the question number 1 of, and we discussed that, but for your memory refreshment, I did it again. Question number 2 and part A is saying that with the aid of a label diagram showing the apparatus needed, describe how you would demonstrate Brownian motion for smoke particle in the air. Draw also the typical path of smoke particles in the smoke cell. Ladies and gentlemen, if you want to see this answer in the 52nd lecture for the observation of Brownian motion, we drew a label diagram in which there was a smoke cell which was sealed. There was a smoke cell which was sealed, and there were smoke particles, because we cannot see these uh, molecules, so we want to see the molecules as a smoke particles. So that was the story, that they were concentrated on this area when the light was coming from the light source there, and it was coming out from a slit like this. So they were spreading. There was a lens which is known as double convex lens. Simply we can say lens, convex lens, and there was the smoke uh, chamber was under the microscope, so we were seeing these microscope. I drew it for you people again, but we did that in greater detail. The job of this convex lens is to concentrate that these parallel lines of light coming from the light source at a particular position so that we can observe the smoke particles. Now the part of this question second part of the A question, they are saying that draw the motion. So they are moving randomly and very fastly with the speed, and they are colliding amongst themselves as well as with the wall of the container. So you have to keep this in mind. That was the whole story. This is a light source because we are labeling it. This is the smoke particle. This is a smoke cell, which is also called smoke chamber. This is the microscope. We are only making the eyepiece of that microscope, not the whole microscope. So this is a sealed one in the glass. This is glass, you should say. Glass smoke cell which is sealed, and it is under the observation of microscope. So this was, and they are asking that show the motion of the uh, draw also typical path of a smoke particle in the smoke cell, which was this one. So it is random. They were randomly. Why? I told you at that point that air molecules is hitting the smoke molecules, and we are portraying these smoke particles is a molecule, is an atom. How the atoms or molecules are behaving inside this container, we are portraying that by the smoke particles. When the smoke particle is hit, it is going in that direction. Because molecules and atoms are so small things that we cannot see even by a high resolving microscope. So Robert Brown made this smoke particles as the molecules. Now we are turning our focus to the B part of question number 2. What is the effect of raising the temperature of the air molecules? When we are raising, these are the air's molecules, and if we are raising the temperature by any means, if we are raising the temperature by any means, they are start moving rigorously. They are moving fast, and they will move towards the wall of the container with a high speed, putting a very high pressure on the walls of the container. So that is why we are saying that when we increase, we are giving energy to these air particles. When they are getting energy, it means that they are moving fast. and they are putting pressure on the wall. If it is in balloon, these particle, then the balloon is inflated because these particles of air putting pressure on the wall of that balloon, and as a result the balloon is inflated. We did two questions of the structure. Tomorrow we will do the third question and so on. So stay with us. Thank you very much for watching. Allah Hafiz.